inequalities. We're going to be finding the solution to these systems. The solution to a system is where the two graphs cross. It's the intersection of the two graphs. If we're talking about equations, those graphs will cross at one or more points. Okay? If we're talking about an inequality, those graphs cross at a lot of points. Okay? First, we're going to talk about two linear equations. Linear equations is two lines. Okay? The easiest way to solve two systems of linear equations is to use your calculator to do that. Okay? So you'll put one equation in as y1, the other one in as y2, and then go calculate the point of intersection. Go find the intersection. That's your solution, that xy coordinate. Okay? And so when we're looking at problem number 1, before we can put this in our calculator, what do we have to do? Set it equal to y equals, because you have to put in your calculator as y equals, right? And so for both of those, you have to solve for y. You're putting it in slope-intercept form. Y equals mx plus b. Okay? So go put those in your calculator, and then go second calculate intersection. Choose the two graphs and find the point of intersection. So for the first one, we'll move the 2x over, and you get y equals negative 2x plus 5. For the second one, we'll move the x over, and you get y equals x minus 1. So you'll put those in as y1 and y2. Good. So you're going to graph both of them, and then you're going to go to second, calculate, and you're going to go down to option number 5, which is intersect. And then it's going to ask you first curve, second curve, guess. First curve, they call every graph a curve. Even though it's a straight line, it's not a curve. But they call it, the calculator calls every graph a curve. And so you have to tell it which two graphs you want it to find the intersection between. Because if you graph more than two equations, say you graph, it will graph 4 different lines. And so if you're finding the point of intersection, you have to specify what two you want it to find the intersection between. So that's why it's asking you first curve, second curve. And so you'll make your cursor will automatically jump on one line, you hit enter, it'll jump down to the second line, you'll hit enter, and then it'll say, now do you want me to guess? And you'll hit enter, and it'll tell you that point of intersection is what? Okay. So we found our point of intersection is x equals 2, y equals 1. That's a point, because you have two straight lines. They intersect in one point. Okay? Try number 2. So first we have to solve both of these for y. So we bring the x over, so you get y equals x plus 3. And here we bring 2x over, so you get y equals negative 2x minus 3. And then you put those in your calculator as y1 and y2. And what'd y'all get? Negative 2, 1. Okay, so that's the solution. That's the point of intersection between those two lines. Those are linear equations. Okay. Now, the other day, when we had that problem where we had a quadrilateral inscribed inside of a circle, and you had to find those angles, and we knew that the opposite angles were supplementary, and we had to set up a system of equations and solve it, right? And you did that algebraically, okay? And so let's refresh our skills on how to solve these systems algebraically. Now, if you have two linear equations, I would generally always choose to use my calculator to find those, okay? But if they're not both linear, for example, if one of them is a quadratic and the other one is a linear, okay? How do we know? First of all, how do we know that both of these are linear? Nothing squared, nothing to the third power. both of the exponents for x and y are to the first power. So that's how we know that they're linear. If either x or y, if one of them is squared, that's quadratic. That means, what's the shape of the graph going to look like? Anybody know? A parabola. Yeah. So it's going to look like a parabola. So if you have a line and a parabola, that intersection will cross it in either 1 point or 2 points. Okay? If you have, how will we know if it was a circle? No, not cube. That's a cubic. If circle, x and y will both be squared. Okay? And so if you have a line and a circle, the point of intersection, again, could be just 1 point or 2 points. You can't solve those graphically because if you have one or both of the variables squared, there's a possibility that your calculator can't graph it because it's not a function. Circles are functions. So your calculator can't graph a function. Okay? And if it's a parabola that goes up or down, your calculator can graph it. But if it's a parabola that goes left or right, your calculator can't graph that. Why? It's not a function. Fails the vertical line test. So when you have two linear equations, use your calculator to graph them. But when you have a linear and some other type, you can only do that algebraically. Okay? So let's refresh our skills on how we do that. Okay? First, before we do that, let's talk about this. This question doesn't want us to find the solution. It just says, how many solutions does it have? You have three options. It's either going to have both of these. What types of equations are both of these? Linear, right? So they're two straight lines. So they're either going to cross at 1 point, no points, or all points. Okay? If there's no solution, what kind of lines are they? Parallel lines. They don't cross at all. They're parallel lines. If there's infinite solutions, what kind of lines are they? They're the same line, one on top of the other. Okay? And so without having to find the solution, we could put these in slope-intercept form and compare their slopes and y-intercepts, and that'll tell me how many solutions they have. Because if they have the same slope but different y-intercepts, that means what? If they have the same slope but different y-intercepts, they're parallel. That means their slope is the same like railroad tracks, and they cross the y-axis at different places, so they're parallel lines. If they have the same slope and the same y-intercept, it's the same line. It's infinite solutions, right? If they have a different slope, I don't care about the y-intercepts. If the slopes are different, they are guaranteed to cross in 1 point, because that means that eventually they'll cross if the slopes are different. Okay? And so take both of these, put them in slope-intercept form, and compare their slopes and y-intercepts. Now, there's other ways to look at these and just figure it out. If they're the same line, you can make them be the same equation. Right? Okay, if the equations are the same, then they're the same line. Are these the same line? Yes. Yeah, if I took the second equation and divided everything by 2, it would match the first one, right? No? Let's solve the first one for y. So it'll be negative 2y equals negative 3x plus 6. Now we divide everything by negative 2. So y equals 3/2 x minus 3, right? So let's solve the second one for y. So we'll move the 6x over. So negative 4y equals negative 6x plus 12. Divide by negative 4. So y equals 3/2 x minus 3. Same line. So if they're the same line, they have infinite solutions. Okay, so they're the same line. That means they intersect at every single point. So there's infinite solutions. Okay, so let's refresh our skills on solving this system using either elimination And then again, same system using substitution. Okay? Now, elimination is also sometimes called linear combination. Elimination can only be used if both systems are linear. If one of them is not linear, you can only do substitution. Okay? So, elimination, or sometimes called linear combination. That's what we did when we, whenever we solved the two equations, two unknowns in that quadrilateral. You force one of the variables to be eliminated so that you can solve for the other one and then go back and plug it in. And so we have 3x plus y equals 5. And then I have x minus y equals 7. So if I want one of those to be eliminated, it's already set up for that to happen, right? I don't have to manipulate either one of them to make those y's cancel. It's already set up that way. And so these y's cancel, leaving me with 4x equals 12. Divide by 4, and x equals what? 3. Okay? We have the first part of our solution. The first part is x is 3. Now we're going to go find y by going back and plugging it in. And you can plug it in to either equation. You can plug it into either equation. So I have x minus y equals 7. So 3 minus y equals 7. So negative y equals 4. So y equals negative 4. So my solution is the point 3, negative 4. That's the point of intersection between those two lines. Okay? Let's take the same system and use substitution. Now, when we do substitution, what do we do? Yes.
You're going to leave y of x, but you leave one of the values by itself and then plug it in on the other one.
Yes. So you solve one of the equations for either one of the variables, solve for x or solve for y, and then go back and plug it in to the equation you didn't use. Okay? That, in a sense, eliminates one of your variables. All right? And so I will solve for, in this one, in the second equation, I'll solve for x because it's already got a positive 1 coefficient. So that's the easiest thing to do. And so I'm going to change this to x equals y plus 7. And now, since x equals y plus 7, I take it and I plug it back in for x in my first equation. And what that does is it eliminates the x. The x is gone, leaving me only y's. So we solve for y, go back and plug it in. That's substitution. This is the method that we're going to use when we have a linear equation and a nonlinear equation. It's the only method you can do. And so we have 3x plus y equals 5. So instead of x, we're going to put y plus 7 plus y equals 5. I substituted in y plus 7 for x. Okay? So then we have 3y plus 21 plus y equals 5. 3y plus y is 4y plus 21 equals 5. Subtract 21 from both sides. 4y equals negative 16. Divide by 4, and y equals negative 4. So, I have the first part, or half of my solution. I know what y is. So how do we find x? Go back and plug it in. And you already have, okay, you need to work smarter and not harder. You already have x equals right here. So go back and plug it in right here. Remember, you can plug y back into any one of the equations at any step of the way. Okay? And so you already have x equals y plus 7, so plug it in right here. So x equals negative 4 plus 7, so x equals 3. Okay? If you have two linear equations that you're finding the solution, if you use elimination, the elimination method, where you're combining both of the linear combinations, okay? If both of the variables cancel, your x cancels and your y cancels, and your resulting statement is true, you'll have a constant equal to a constant. If it's 0 equals 0, if it's true, then that means your answer is infinite solutions, because that means they're the same line. That means that your slope and your y-intercept was both the same. So that means they're the same line. If both your variables cancel and the resulting statement is false, that means your slopes were the same, because the number in front of x's were the same, but your y-intercepts were different. That's the only way that can happen. Okay? That means your slopes were the same and the y, so that means there were parallel lines. So there's no solution. Okay? So if you solve these algebraically and you see that all your variables cancel, you have to check to see if the resulting statement is true or false. If it's true, infinite solution. If it's false, no solution. If you took those and graphed them, you'll either see two parallel lines, and when you try to do the intersection, it won't find a point of intersection. That means no solution. Or if you graph them and you only see one line on the graph, it's because both equations were the same line. Okay? And so when we look at this problem, if we try to combine these, I would multiply the bottom by 4 to try to get my x's or my y's to cancel. And what would happen is, my top equation doesn't change. Negative 8x plus 12y equals 24. My bottom equation becomes positive 8x minus 12y equals negative 24. And what happens is, everything cancels. So you end up with 0 equals 0. That's true. That's true. So that means they're the same line. That means they're infinite solutions. Okay, solve that using substitution. Okay, so I would solve this one for x, because that's the easiest thing to do. So x equals 4y plus 13. And then we go back and plug it in right here for x. So we have 2 times 4y plus 13 equals, no, plus 3y equals negative 7. So you get 8y plus 26 plus 3y equals negative 7. So you get 11y plus 26 equals negative 7. You subtract 26 from both sides, and you get 11y equals negative 33. Divide by 11, and you get y equals negative 3. So my solution, my y value, is negative 3. Now I take it and plug it back in and see what x is. So x equals 4 times negative 3 plus 13. So x equals negative 12 plus 13. So x equals 1. Now we're going to solve a system where one is linear and the other is a circle. So in a circle, the equation, you have x and y are both squared, right? The only way you can do that is to do substitution. So you have the tools you need to do this. You just need to remember all your algebra skills. It's going to look messy at first, but then you're going to simplify everything and it's going to end up beautiful. So this is a circle and a line. So you have to solve this using substitution. Okay. So you're going to solve for y in your second equation. So you'll get y equals positive 3x minus 4. Okay? That's what y is equal. So be careful. When you plug it back into your first equation, you're going to plug it in right here and right there. So let me help you get that set up. So we'll have 5x squared plus 3x minus 4 squared minus 7x plus 3x minus 4 plus 2 equals 0. I substituted in 3x minus 4 for y. So we can solve for x. Same concept of what we did in this problem before. Except that now we need to follow our rules for how we solve equations. Okay? 3x minus 4 squared, is that 9x minus 16? Absolutely not. What do you have to do with that? Expand it. Make it 3x minus 4 times 3x minus 4, then distribute. Then you can combine all your like terms in one step and you'll end up with something x plus something equals 0. So it's not difficult, it's just tedious. You have, yes, you'll end up having to use the AC method. It will be a 1. So, like I said, work smarter, not harder. So if you end up with, and if you're not to this step yet, you will understand what I'm talking about in a minute. When you get to the end and you have your quadratic equation, if you can divide everything by something to make those numbers smaller, do that. Okay, so you have 5x squared plus 3x minus 4 times 3x minus 4 minus 7x plus 3x minus 4 plus 2 equals 0. You have to multiply all that out. You have to distribute that. 5x squared. Once you multiply this out, you should end up with 9x squared minus 24x plus 16, then minus 7x plus 3x minus 4 plus 2 equals 0. Now when you combine all your like terms, you end up with 14x squared okay, it's minus 28x plus 14 equals 0. Okay, listen. At this point, you could attempt to try to use the AC method, But that would be messy. Okay? I can still simplify this more. If I divide everything on the left and the right by 14, that'll reduce those numbers drastically. Okay? So if I divide everything by 14, I end up with x squared minus 2x plus 1 equals 0. Now, the other option would have been to factor out of 14. You could have factored out of 14, but then you're only doing something to the left-hand side. You would end up with 14 times all of that on the left, which is fine. After you use the AC method to factor that, remember, then you set each thing equal to 0. So you would have 14 equals 0, which would be thrown away anyway. Okay? So, if everything in your equation can be divided by that greatest common factor, then do that, and it eliminates it completely. Because we divide the left and the right by 14. 0 divided by 14 is still just 0. Okay, so if you can do that, do that. And so now we do our AC method, and when you do, you end up with x minus 1 times x minus 1 equals 0. Or if you factored out a 14, you would still have a 14 here, okay? But that ends up going away in the end anyway. And so now, when you set each one equal to 0, you end up with x equals 1 and x equals 1. Now, since those are the same, we are only to assume that there's one point of intersection. You're not going to go back and substitute in x equals 1 twice, right? When we take x equals 1 and we plug it back into here, we'll get y equals 3x minus 4. So y equals 3 times 1. So y equals negative 1. So our solution is the point 1, negative 1. What does that tell us?
So we went so hard to take one.
We did, but our first equation was what? A circle. And our second equation was a line. They only intersect at one point. What does that tell us? The line is a tangent line. And you were saying the same thing. If they only intersect in one point, that line's a tangent line. Okay? Because if you have a circle and a line, if it goes through it, it's going to intersect at 2 points. What kind of line is that? No, chord. It's a secant line. Secant line intersects a circle in 2 points. If here's our circle and it only intersects it in 1 point, that's a tangent line. Okay? If it doesn't intersect it at all, there's no solution. Okay? Remember, a solution is where the two graphs intersect. A solution is where the two graphs intersect. When you're dealing with inequalities, the graph of an inequality is not just a line. It's a line and then everything shaded either above or below it. So where those two shadings intersect is your solution to a system of inequalities. Now, your calculator also can do this for you. All these inequalities, now we're not doing inequalities, they're all linear inequalities. They're both linear all the time, okay? And so you can do these on your calculator for the most part. These are already set up, y equals, okay? When you put these in your calculator, if they're not set up y equals, you need to do that. You need to make sure that when you're solving for y in these inequalities, that if you have to multiply or divide by a negative number, you have to do what? What do you have to do? If you divide by a negative number when you're solving for y in an inequality, you have to switch the inequality. Okay? So if you have to divide everything by negative 2, that less than is going to turn into a greater than. Okay? Which matters. It matters when you graph it. Okay? So what I want you to do right now is I want you to put the first one in as y1 and the second one in as y2. And it's going to be y equals y equals. We're going to tell the calculator that it's an inequality. If you move that cursor over to right before and hit enter, it'll change what's in front of it. Now, yes, move the cursor over to before the y. Okay, now, we read these inequalities just like we read a book from left to right, correct? Right? This is opening to the right-hand side, correct? Okay, y'all listen. This right here is saying that the right-hand side is the larger side, correct? So when I'm reading it from left to right, you say y is less than, okay? Less than means you shade below. Greater than means you shade above. So when you hit enter, this is you want it to put that little symbol that looks like this. That means it's going to shade everything below it, because that's less than. Okay, so you see why it's important that if you have to reverse that inequality, it matters? It matters, because when you tell your calculator to go to shade it, you're going to tell it to shade the wrong side, and your answer will be wrong. Okay? Now, your solution is that double shaded area. It's where both are shaded simultaneously. Okay? Because all of those points in that double shaded area, all those points make both of these statements true. Okay, I'm going to do this manually. Okay? You have done it on your calculator. I'm going to do it manually using the slope and the y-intercept to graph these lines. Okay? So, for the first one, well, I'll do the first one in red and the second in blue. Okay, so for the first one, it crosses the y-axis at 2. And then I go up 1 over 3. Or down 1 to the left 3. Now, remember, when you're graphing these manually, you either have to put a solid line or a dashed line. What determines that? The equal to bar. If it has the equal to bar, it's a solid line.
Yes.
If not, it's a dash. Okay? So this is a solid line. All right? Now, oh, that's in red. Let me do it again. Okay, let's do the blue one. So I go down to 3, and then I go either down 4 to the left 4, or up 4. Oh, I mean down 4 and to the right 3, or up 4 and to the left 3. And again, it's a solid line. Okay. Now, the red line, I have to shade everything below it. So it's everything underneath here.
No.
And the blue line, I have to shade below it. So my double shaded area
See, I was right. That was right. I didn't realize there was someone that.
oh, it's not supposed to happen. Okay. So that's where both graphs are shaded. Because if you shade the red one, it's all this. And if you shade the blue one, it's all this. And this area is where both of them are shaded. Okay? So, if I pick a point and I ask you, is it a solution? If the question is the point 1, 1 a solution to this system? 1, 1 is right here. That is not a solution to the system. It is a solution to the red equation, because it's in the red shaded area. But it's not in the blue shaded area, so it's not a solution to the system. Okay? That's how they'll pose the questions. They'll give you two or three inequalities, and they'll say, is the point 4, -5 a solution? your options are graph it and see if it's in the intersected shaded area, or plug that point into both equations and see if it makes them both true. It has to make all of them true for it to be a solution. Okay? You're on this final exam, you're not going to have 2. You'll have 3. Okay? You'll have 3 inequalities. Your calculator can graph almost any inequality. Can anybody think of an inequality it can't graph? Okay, let me pose this question. Your calculator can graph almost every line. No, I'm talking about just a line, straight line. What kind of line can it not graph? A vertical line. Why? It's not a function. It won't graph a vertical line. How will a vertical line look? Give me an example of an equation of a vertical line. X equals. X equals. Think about it. If one of the equations is x equals something, can you put that in your calculator?
No.
No. When you go to graph it, it's y equals. You can't change that to x equals. Okay? So, if you have to graph an inequality, or if you're trying to graph an equation and it's x equals something, you can't put it in your calculator. You have to graph that yourself because it's a vertical line. So I just wanted to remind you of that. Okay, so I want you to try this one. Yes, graph it and find the triple shaded area. Okay? This is how it'll be on the final exam. And then the question might read, is 4-2 a solution?
You divide everything by 3.
So, move the 2x over. Negative 3y greater than negative 2x minus 6. Divide everything by negative 3. Divide everything by negative 3. You have to switch this around. So if you divide this negative 2 by negative 3, that's positive 2/3. Negative 6 divided by negative 3, positive 2. Okay, so when you solve for the second one, you should get y greater than 5/3 x minus 1. And then when you solve for the last one,
What the heck?
3y greater than negative x minus 3, and then y greater than negative 1/3 x minus 1. You divide everything by 3. So now I'm going to graph all these manually because I only divided by positives. You only switch it if you divide by negative. Okay, so the first one, I'm going to graph this manually. So the first one crosses at 2 and goes up 2 and over 3.
Oh, see, I did
And that's a dotted line.
Oh, shoot. I did that wrong so badly.
The next one crosses at negative 1. And it goes up 5 and over 3. And it's a dotted line. The next one again crosses at negative 1. And it goes down 1 and to the right 3. Or up 1 and to the left 3.
You said Oblivious.
Hey guys. So I have my 3 lines graphed, but I don't have the inequalities parts graphed yet. So for the red line, what else shade above or below? Below. So everything under here, right? So my red line would shade everything under here. My blue line, above or below? Above. And my green line? Above. So my triple shaded area is in there. My little triangle in there. Because my red line would be below. My blue line,
And the green one, negative 1/3 is positive.
Yeah.
why?
The one that you divide by is not negative. The three that you divide by is a
Yeah, when you bring the x over, it's negative x. So my blue line, shades above, so it's all of this. So right now, see that yellow area has red and blue. And then my green shades above. So this piece here is where they're all have in common. So the question was, is the point 42 a solution?
No.
So we find the point 42. So 1, 2, 3, 4, 1, 2. That's right here. Is that a solution? No.